Alright guys, here are the objectives for today. I will compare areas of rectangles that have the same perimeter. Okay, so rectangles we're going to see have the same perimeter but different areas. Okay, and our second objective, we're going to compare perimeters of rectangles that have the same area. So rectangles having the same area but different perimeters. So let's start with our first example. Alright, so here are two rectangles. Rectangle A, rectangle B. Alright, so first we are going to figure out the perimeter for each figure, and then we'll figure out the area. Alright, so let's first look at rectangle A, okay? Figure A, they only gave us this side, okay? This side of figure A. I wonder why. So if this side is 5 meters, oh, they only gave one side for a reason, because this is a square, and I know that squares have all equal sides. So if this side is 5 meters, you guys, all of the sides are also 5 meters. And I'm going to go ahead and write that in. 5 meters all the way around. Okay, so let's figure out the perimeter. I know perimeter, I add all the way around the figure. So 5 meters plus 5 plus 5 plus 5 meters. And that, I could even use multiplication. 5 times 4, because there are 4 sides of the figure, is 20. So the perimeter for rectangle A is 20 meters. We know the units, meters, okay? Well, let's figure out the area for square A. Well, I know area, we multiply. When we are solving for area for rectangles and squares, we multiply the length times the width. So we're multiplying 2 of the sides only. So it doesn't matter what 2 sides for figure A, we can multiply this side by this side. And I know that, let's write 5 meters times 5 meters equals 25 square meters, because I'm solving for area, right? So for figure A, the area is 25 square meters, okay? Well, let's compare rectangle B. Again, we know that rectangles have opposite sides that are equal. So let me just go ahead and finish writing that out. So if this side is 2 meters, you guys, this side is 2 meters. And again, if this longer side is 8 meters, then this opposite side of it is also 8 meters. So let's solve for perimeter for rectangle B. Again, perimeter, we add all the way around the outside of the figure. So that's saying 8 plus 2 plus 8 plus 2. Remember, and we are talking about meters. All right, well, I know 8 plus 8 is 16, and 2 plus 2 is 4, and 16 plus 4 is 20. 20 meters for perimeter. Okay, so for rectangle B, the perimeter is 20 meters. Now, let's solve for area. We know area is length times width. 8 times 2, 8 meters times 2 meters equals 16 square meters. So I'm going to write that down here. 16 square meters. Now that we wrote everything down, now let's figure out which rectangle has a greater area. Well, for figure A, the area is 25 square meters, and for figure B, the area is 16 square meters. Because 25 square meters is larger, right? 25 is larger than 16. That means that figure A, rectangle A, has a greater area. Okay, let's do another example. So this example, we knew that these figures had the same perimeter but different areas. Now let's look at these two figures. All right, now we're going to find the perimeter and the area and tell which rectangle has a greater perimeter, okay? All right, so let's solve for area first. Let's look at this figure. Well, length times width, okay? Looks like all sides are equal. Just filling that in. But I know that 6 times 6 centimeters equals 36 square units for figure A. It's a perfect square. 36 square centimeters is the area for this square. All right, let's look at perimeter. We know perimeter, we're going to add all the way around this figure. So basically 6 plus 6 plus 6 plus 6 centimeters is 24. 24 centimeters, right? So that's perimeter. Now let's solve for B. Let's find rectangle B's area and perimeter, starting with area. Well, if this side of the rectangle is 4 centimeters, then this side is 4 centimeters. If this side is 9 centimeters, then this side is 9 centimeters. Opposite sides are equal of a rectangle. But we're solving for area, okay? And area is length times width. So here's the longer side, 9 centimeters times the shorter side, 4 centimeters. And boys and girls, because of the commutative property of multiplication, remember, it doesn't matter if you multiply the shorter side times the longer side, you will still get the same answer. And 9 times 4, or 4 times 9, is 36 square centimeters. All right? Now, perimeter. Perimeter is the distance around the outside of the figure, and we are adding. So let's see, 9 plus this side is 4 centimeters, plus this side is 9 centimeters, plus this side is 4. And I know several of you like to add 9. You like to add the doubles first. Like 9 plus 9 is 18. Oh, I'm sorry, I forgot to put my C here for centimeters. And then I know a lot of you will go 4 plus 4 centimeters is 8 centimeters. And you can do that as well. And 18 plus 8 is what? Very good, 26 centimeters. And that's the perimeter for rectangle B. All right, so let's look. Which figure has a greater perimeter? Well, let's look. Perimeter A is 24 centimeters, and for figure B is 26. Oh, we know that 26 is larger than 24, so that means rectangle B has a greater perimeter. All right, let's look at another example. All right, I know you'll have this example in Seesaw. Sophia Taylor drew 4 different rectangles, each having a perimeter of 28 inches. All right, so each of her rectangles, all 4 of her rectangles have a perimeter of 28 inches. So all the way around her rectangles have 28 inches. The question says, which rectangle has the greatest area? Oh, that's a good question. Which rectangle has the greatest area? Okay, so we know. What do we know about area? How do we solve area? Length times width. We can definitely, when we have a rectangle and we see the square units inside the figure, we can count those square units. But let's look at our answer choices. All right, look at A. All it says is 11 inches by 3 inches. Now remember, boys and girls, Sophia has how many rectangles? She has 4 different rectangles, okay? So basically, like figure A, well, problem choice A, it's saying the measurements are 11 inches by 3 inches, okay? That's what her first rectangle looks like, okay? So we're trying to figure out which of her rectangles has the greatest area. Well, if area is length times width, 11 inches times 3. We're multiplying 11 times 3, boys and girls, and that is 33 square inches, okay? Keep that in mind. Well, let's look at B. I'm going to solve all 4 of these, and then I'm going to look back and see which one is larger. So B says her rectangle is 10 inches, so this is the long side, by 4 inches. So what would the area be for choice B? Well, length times width is how we would solve to find area of a rectangle. And I know that 10 inches times 4 inches is 40 square inches. Okay? So that represents her rectangle B. Look at C. 9 inches. That has to be the long side by 5 inches, the width, the shorter side. Think, what is 9, the length, times this width? 9 times 5 is 45. 45 square inches. Remember, we're solving for area. We cannot forget about our unit, which is inches. We cannot forget about the square. Last but not least, look at D. Let me draw my rectangle. This is Sophia's last rectangle. It says 7 inches by 7 inches. Oh, it looks like it's perfectly a square, so really needs to look more like this. 7 inches. All sides are equal. But we're solving for area, so we just need to multiply 2 of the sides. 7 times 7 inches is 49 square inches. Now I know I'm going a little faster just because Ms. Stevenson knows all of her facts, and I know you do too. And I know sometimes we just need to make sure we use repeated addition, draw an array, or even draw equal groups to help you with your multiplication problems, and that's no problem. Okay, so let's look back at all of these areas for Sophia's 4 different rectangles. Now, all of these rectangles, remember, they do have the same perimeter, but we're trying to figure out which rectangle has the greatest area. So let's focus on that. So 33 square inches, 40, 45, and where's this? Oh, 49 square inches. So, boys and girls, which one's larger? 33, 40, 45, or 49? Which number is larger? The largest. 49 square inches, and that represents D. So that's why I would circle D. So this rectangle down here, choice D, is Sophia's rectangle that has the greatest area. Okay? And so we just reviewed rectangles that have either same perimeter but different areas, or rectangles that have the same area but with different perimeters. And just make sure, guys, as you are solving, make sure you remember area, we multiply the length times width, L times W, and for perimeter, we add all of the sides, all of the outside sides, right? Okay, you got this.